Ladies and gentlemen, please welcome Merve Noyan.
And you are live. Please share your screen and then you can just start off.
Hello there, I'm Merve. I'm Google developer expert on machine learning, and today I will talk about language models. First, I will begin with what are language models and if computers actually
Merve,
understand
can you just
us.
share your
And,
screen? Yeah. Right.
I just
Slideshow,
did, but
please.
doesn't it?
Yeah.
Does it?
Yeah.
Does it? Does it? Can you see?
Yeah, it's
Can you
perfect. It's
see it
perfect.
right
It's
now?
going good. Yeah,
Okay.
perfect. It's perfect.
Okay. I will firstly talk about, what are language models, what they can and can't do, and democratization of AI, new trends, and, the environmental damage by training language models, and will we ever get unemployed by language models? And then we will have a Q&A. So, what are language models? By definition, it is a statistical model that assesses a probability of for a word, like whether if it's said by a human or not. But this is a very, very general definition. By the end of this session, you will gather an understanding of what is a language model. But let's ask the question: if computers really understand us, how do they understand us? This actually depends on how we understand the world, and maybe they are mimicking our understanding. The most basic language model ever is a basic word-word coherence matrix. And for instance, you have this IMDb data, and in the you have this whole big corpus, and you make a matrix out of it, and this matrix basically consists of each word co-occurring with each other, if it's is it next to it or not. For instance, you can ask the question who is the director of The Dark Knight, and you have multiple choices, and you can just run over all of the choices, how many times they appear with The Dark Knight, and you will get the answer, Christopher Nolan. So this is the most basic representation ever, but it is huge. You have so many columns and rows, multiply it with integer 32. So you cannot really keep it that way. Instead, we keep our words as word vectors. What are word vectors? The most primal, so to say, representation of word vector is GLOVE by Stanford NLP. And it's a basic mathematical calculation, dot product of two words of their vectors equals to log probability of them co-occurring together. But there is a relationship between those word vectors representations, and here you can see some of them. It explains the relationship between them, but we don't really use GLOVE as well. So this is one of my favorite projects of TensorFlow. It's called TensorFlow Embedding Projector. It has so many. It has few models like Word2Vec. It gathers all of the word vectors, and they are called embeddings, and they are on multiple dimensions. And you basically type a word to the search box and get the words closest to it. For instance, I type the word forest, and I get vegetation, crops, lakes, and everything. You can change the distance metric. You can change the dimensionality reduction method, we have PCA, TSNE. These have many dimensions, but for the sake of visualization, they're actually reduced to 3 dimensions. Actually 2 dimensions, but 3 dimensions you can see here. With I hope you can see them here. In the y-axis, you have a green
your
line.
Slides aren't changing. It's stuck. Your slides are stuck.
Can we do
Yeah.
these? Can we do this? Or wait. Yeah, let me share my desktop instead. Like in here, you can see there is this axis, like this is y-axis and z and x, but they're like very, very reduced to dimensions. Can you currently see the screen?
No, your slides aren't shown yet. I mean, it's not shared yet.
Wait. You should be able to see
Yeah, now it's fine.
now. So you have these
No, it's
three axes in here. Let me continue. Can you mute yourself because there's huge noise in the background? Is it fine? Yeah. So check out TensorFlow Projector and also What Lies by Vincent. It's a great project. And also you can check out Glove and Word2Vec. These are two methods to gather word embeddings out of a corpus. Word2Vec actually includes scriptgram and CBOW methods and neural network. And in here, I typed the word queen, and you get Elizabeth, like Anne, King, Mary, etc. Yeah, these are basically the probability of the word co-occurring with the word queen. So do the computers actually understand us? Yeah, if this is understanding. Second thing, we used to have actually recurrent neural networks. They're basically, this architecture is adapted for sequential data, like time series and genes and texts. There's a sequence, and you just feed it, and it captures the relations between the words and in a sentence. And for instance, like third word in a sentence gathers the meaning of, like, the feeds of the first word and the second word as well. So that's why they are useful. They are not like densely connected neural networks or like CNNs, but we are not using them anymore. Second thing is bidirectional RNN. People basically didn't think that the third word should only make use of the first and the second word. Instead, it should also make use of the words that come after the third word. So they made it like bidirectional from both left to right and right to left. So the unidirectional RNNs are not used anymore. Rather, it's bidirectional RNN. And we have dependency trees. Dependency trees are basically explains the relationships between words, and we have long dependencies in long sentences. But they are not really gathered in the RNNs well. Instead, the state of art is on transformers. So yeah, transformers gather better understanding in the longer sequences because they use something called self-attention. They capture meanings better than bidirectional RNNs or recurrent neural networks. That's why they are used the most. And the last thing is called, before I proceed with the language models, is called transfer learning. Transfer learning is basically you have this big model. In computer vision, we have VGG and ResNets. In language models, I will talk about later, we have BERT, GPT-2, and we get the first 2 or 3 or more layers of these models, and then we freeze them. And we change the classifier layer, which is the last layer of dense layer, with our task-specific custom layers. And we also unfreeze the layer before the classifier layer. The reason why we are using it is for instance, you have this big model that you cannot train at home, that somebody else have trained it for you with huge data. And that was trained to recognize cars, and you want to recognize trucks, which is very similar to cars. So you take this huge
Merve.
model. Yeah.
Excuse me, Merve. Your slides are again stuck on the number 6.
I'm talking about transfer learning right now.
Now it shows transfer
Um,
learning. Now it shows transfer learning.
Okay.
Yeah, you can continue.
Okay. So you have this huge model that somebody else has trained for you. For the computer vision, it's VGG, and for language model, it is BERT. And then you take it and you freeze the earlier layers. Reason why you are doing is that, for instance, for computer vision, the earlier layers actually capture representations for shapes, textures, like universal representations, corners and edges. For NLP, it's more like it can be linguistic syntax and other things. And you unfreeze the layer before your task specific layer that you have put. Your task specific layer is basically at the end. And then you train it again so that it saves you from huge burden of learning, trying to learn more basic stuff. So that's why we use transfer learning in context of natural language processing. So what are language models? I will talk about all of these later on again, but what are language models? That's where my presentation actually starts. So most famous ones are BERT by Google, GPTs, Elmo, Ernie, and T5. They all have their own design considerations. They all have their way of trying to mimic how the humans actually understand, talk. For instance, BERT only talks about, BERT is on only consists of encoder layers. Meanwhile, GPT is on decoder layers. In here, you can see, by the way, a transformer architecture, which basically captures these dependencies better than RNNs. This is called, the left-hand plane is called encoder, and the right-hand plane is called decoder. And we have Elmo, which is basically left to right and right to left RNNs. BERT is called bidirectional encoding representations, but like it is not bidirectional, it is actually non-directional because you feed the words all together. It is called masked language model, and it is actually trained for 2 tasks. First is masked language model, and second one is next sentence prediction. Masked language models is inspired by the closed task, basically fill in the gaps. They have this training data and they mask the 15% of the words inside it. And GPT is a little different. It does generative pre-training and then discrimination in the fine-tuning, etc. But what can they do? Like, they can mimic language, they can do paraphrasing, they can do question answering, generate texts, as you can see in the internet a lot lately with the GPT-3. They can do summarization, translation, and entity and intent recognition. This is what we use a lot in chatbots. Yeah, they can actually do these by, by fine-tuning the models. Wait. Yeah, fine-tuning the models Like we feed specific data sets. For instance, we have squad data set, which is for question answering. We have a specific data set for name density recognition, and we feed them to, for instance, BERT, and we can just make them do these things all together. And what they can't do is that they cannot be creative, first of all. For instance, you can see in the internet that people use GPT-3 to generate art or like poems, but it's not really creation. Like it's a whole big question if robots can actually ever become creative. Are we creative? Like, do we create as well? Since we also have like, for instance, someone who lives in the East can see, you know, Orientalist architecture, gets inspired by the Oriental architecture and draws, you know, paintings according to it. Someone who is in the West is way more different, like art is different. And are we also limited to data? So they are limited to the data that they have been trained on. Also, if you ask GPT-3 about COVID-19, it will not say anything, simply because it doesn't have it inside its training data. So it doesn't know about it. They cannot do common sense reasoning. In language models, we test language models according to tasks. We have, for instance, Glue. We have Cola. We have Vinograd Schema Challenge. Like, for instance, Vinograd Schema Challenge basically measures how does a language model perform in common sense reasoning. And most of them actually do not do pretty well in common sense reasoning. They cannot reason. It's very artificial kind of reasoning. They do not really have magic. For example, I've seen Gary Marcus's article on GPT-3 and they have tried it. Like, none of us can actually try it unless we get the trial version. But as far as I have seen, they are cherry picking them, cherry picking the outputs. Some of them have logical errors. Like, for instance, they have typed, they have asked GPT to write a story, and you know, it cannot pass through a door simply by opening the door, you know, holding the doorknob and opening the door itself, but like simply removing the door or removing the objects in front of it, which basically fails in logic. And again, they cannot understand in the way that we understand things, which is also very complicated. There are other problems with language models. First one is the gender and racial bias, and second one is the computational cost and the environmental damage of it. So no offense to Hugging Face, I love what they do. They are just serving the GPT-2. This is the output of GPT-2 model. These embeddings are close to words that are very offensive. And the racial bias is basically how a minority group or, you know, a stereotype is associated with some words that are really offensive. And this is basically the output of written by Transformer API of Hugging Face. I just typed Muslim and asked the GPT to complete the sentences for me, and it was kind of about bad stuff. Another thing is gender bias. On left-hand plane, you can see the she, and on right-hand plane, you can see he. And she is more associated with homemaker, sisters, witches, sewing, modeling, and he is more he is co-occurring with the words more like genius, guru, brilliant, rather than these words that she is associated with. And if you want, you can check out the debiasing word embeddings. It's a whole new concept. Like, we are trying to get the bias out of these word embeddings. Another thing with the gender bias is that some folks at Towards Data Science decided to measure the bias. How they measure the bias is the probability of a word being associated with, for instance, woman. And they have also measured the number of parameters in GPT-2. And as the parameters increase, the bias increases. Like, let me explain. On the 0, it is gender neutral. Above it, it is more associated with male, and below it, it's more associated with woman. And, you know, nursing assistant, care worker, midwife, receptionist, as the parameters increase, it is more, these words are more co-occurring with the word woman. And as for the men, as the parameters increase, like the word CEO, engineer, scientist, software developer is more co-occurring with men. So the long story short, increasing parameters, training with bigger data, bigger models is not really solving this gender bias or racial bias issue. Number of parameters, there is an ongoing trend. As you can see, it increases by the time, but the GPT-3 is a very big game changer. It is huge. It is basically huge, but there are downsides to it, and I will talk about them. And before GPT-3, we have Turing NLG by Microsoft, as far as I remember. We have T5 by Google, which is a really cool language model, in my opinion. Before that, we have GPT-2. And questions about democratization of AI. So as the model's parameters increase, it is harder for you to train it on your local computer. And democratization of AI basically means in the development AI, everyone should get a word, rather than some companies gatekeeping and not letting other people in the development of the models. And in my opinion, GPT-3 is basically just serving against the democratization of AI, because it's a huge model. You cannot really move it to anywhere. So also OpenAI just announced that they will simply sell the API, meaning that you will not be able to fine tune it or anything. You will basically send the input and get the output. They will sell it as API, and Microsoft is going to host it. And it is also, and they also said that they will develop more products, just like GPT-3. So it doesn't end with GPT-3. Hopefully, Facebook and Google will not join this trend. So that's actually my opinion. Just it is very open to discussion, by the way. Also, having a control over a specific language model is, in my opinion, basically gatekeeping, because like they basically control who will use the language model and who will not using, like excluding some people from using it. So that's it, in my opinion. And there is environmental damage of training language models. Since like they are training in a distributed way, you can speed up the training process. they want, if you were to train GPT-2 in only one computer, it would take like 27 years. And it generated a carbon emission equaling to total lifetime of 5 cars. And I never calculated the environmental damage, like carbon emission of GPT-3. And the only paper I have found was Emma Strobel's paper on energy considerations, and it's covered until GPT-2. So, but like, just imagine, like, it was equaling total lifetime of 5 cars, like 27 years, and just imagine 355 years is the computing time of GPT-3, and it is huge. And there is a correlation between like the number of parameters and the carbon emissions of language models. So it's a huge damage to the environment, but it doesn't end at this point. It is going to cause more damage during the inference, because NVIDIA basically estimated 80% to 90% of the cost of neural network as a, both monetary and the carbon emission is in inference rather than the training. And final question, will we become unemployed? There is a huge hype about GPT-3. People are just posting codes of GPT-3, like, yeah, it can write codes, it can write SQL queries, it can write like HTML code, it can generate a website. Are we going to become unemployed? In my opinion, no. Because for instance, until now we have covered some JavaScript frameworks, like until GPT-3 came out, it was only trained with the data that had JavaScript frameworks, for instance, until then. And new frameworks on web development, backend, frontend, even machine learning comes, and GPT-3 cannot be really creative on the data that it didn't really see. Also, people really cherry pick the results, and some nested queries. I have seen some nested queries that GPT-3 has failed, and most of the people just like generates like 8 outputs and pick the most successful one. So in my opinion, no. But like, you can write monkey codes with it, but opportunity cost of writing these monkey codes with GPT-3 is basically to write your own code. So it's like people are talking on developers like they are just copying and pasting from Stack Overflow, but like, this is a know-how and you already have the know-how, so why don't you just write monkey codes on your own? So in my opinion, no, not right now. Maybe in a futuristic perspective it will later, but job descriptions change. Like, we didn't have any data scientists like 20 years ago, I guess. Like, jobs die and new jobs are created, and just like this, we will eventually adapt. So in my opinion, the answer is no, but again, this is very open to discussion.